All right, everyone, we're going to go ahead and talk about how to set up and configure the DMA20 Anderson-Hauser magnetic flow meter. As you can see on the screen here, we're getting an error already. It tells us that we've got an empty pipe. Actually, one of the diagnostics that we're going to take a look at when we get into the E&H Smart Blue app. So first things first, when you mount this thing, you need to make sure that you pay close attention to the direction of flow through it. As you can see up here on top of the mag flow meter, there's actually an arrow that says flow direction. So that is the recommended way to install it, although you can flow backwards through this instrument. One of the other things that we want you to pay attention to up here is the model number and then the serial number. That serial number up there is going to be important as we try to get into the Smart Blue app so that we can go ahead and configure this thing. So we're going to go ahead and connect to this thing via Bluetooth. You can see right there that Bluetooth is one of the communication protocols, and the other communication protocol that we can work with is called IO-Link. So with IO-Link, we're going to give you a little lesson later to talk about that as well. I'm going to focus on the Bluetooth, and what I want you to know is the output that I've chosen is not IO-Link. I've chosen 4 to 20 milliamp output. So that's how I actually have the instrument wired up going back into our control system. So that being said, the next thing that we're going to do is we're going to go in and we're going to go ahead and configure this DMA20 for the application we've got here. So again, we're on the instrumentation and control trainer here, and I forced all the flow to go through the meter so that we're not sharing it with the lower run. And what we were able to do was pull off a little bit over 13 gallons a minute. So that being said, if we can go 13 gallons a minute, ideally we're probably going to want to have an upper range value that's just a little bit more than that. So again, as you go into this, I'm not going to back up. The username to get into Smart Blue is admin, all small case, ADMIN. And then the password that you use is actually the serial number that we saw up here, okay? Come back, write the serial number down, and you're going to need it. So that is your password along with the admin username. So once you get into Smart Blue, then what we're going to want to do is go into application. And we click on that. I'll leave my finger. All right, and then we can go into system units. And you can see in there, I've got a choice as to what I want for volumetric flow units. And here, I've chosen gallon per minute. Now, if I want to change it, I could just touch that and I could pick liters per minute, okay? The volume unit, again, is US gallons. And the temperature unit here, I got is Fahrenheit. We could pick Celsius if we wanted to. And then there is an option to do a totalizer inside of this thing as well, okay? And what I'm going to totalize here would have been gallons if I choose to run the totalizer. So it could be a deal where I start the totalizer up at the beginning of a shift, and then I go ahead and have it shut off at the end of a shift. All right? So we're going to come back here, and now we're going to talk about the sensor. We'll just go into that function here and see what we got. And you can see that here is where that arrow direction becomes important. It said the install direction is flow in the arrow direction. Okay, I could choose to change that. If I put this meter in backwards for one reason or another, I could actually change that to tell it that the flow is opposing the arrow direction, and it'll still measure it correctly. Okay. Also down here, you can see that there is a factory low flow cutoff of 0.198 gallon, right? So once we get below 0.198 gallon, we're going to cut it off and say we got no flow. At that point, we start losing our accuracy because our velocity of our fluid is so low that we can't generate the voltage at the electrodes to be able to actually measure correctly. So that's the low flow cutoff. And you can see here that we can also dampen our signal Right now that's set at 0 seconds, so there's no dampening in there. We come back, we're going to take a look at output 1, and you can see, comes up here, that output module 1 is current, so that'd be my 4 to 20 output. And it's what's being assigned to it is the volumetric flow. And so it's 0 gallon per minute. I'll get a 4 milliamp signal out, and you can see I picked 15 gallon per minute for my upper range value of 20 milliamp. Now I told you earlier that this trainer will run about 13 and a half gallons a minute. So 15 would be sufficient to be able to handle that flow rate. Output number 2. We could choose to do an output number 2. Actually, there'd be an opportunity to do that. We could send temperature as a current output if we wanted to do that. We could have a 4 milliamp value of 32 degrees Fahrenheit and a 20 milliamp value of 212 degrees Fahrenheit. So what you're looking at on this meter is the ability to, let's let the air go by. There you go. You see the temperature, 80.2 degrees Fahrenheit. All right, so we actually warm this water up by running it through the pump down there. So I had this pump running for a while. I actually heated that water up just a little bit. Actually, at the end of the day, and when I run water through it, it's actually going to cool it down. You're probably seeing more of an air temperature in there right now. Okay, so back up out of here, and the display. So down here, we can go ahead and pick what we want the display to show. Right here it says volumetric flow and temperature, and it automatically rotates the display based on what direction I install the meter. I might install the meter in an uphill run, and I might install the meter in a parallel run like right now, but it's automatically going to rotate by itself when it senses that it's been turned 90 degrees. And the backlight I've got set at 50% of strength. So if you look up here, you can see that the gallon per minute's there and the temperature is there, just like we've got set up down here. Okay, and we can change that. We can change what that display is. The measured values is the last menu option to get into here, and right here you can see that right now we got 0 gallon per minute. It says 81.19 degrees Fahrenheit. Actually, that's not only a combination of the AIR in there, but it's also the electronics is warming it up in that area. When we got water flowing through there, it's going to wick that temperature out of here. You're going to see that temperature drop. You can see that the totalizer has got 1,452.711 gallons. So at one point I had the totalizer on, actually it's still on, and right below it, reset totalizers on cancel. So I could actually go in here and I could say reset and total and hit OK. All right. And there, you just seen it zero that out. So that's one of the functions you may need to be able to know how to do, is how to zero the totalizer, and it's been done. So now, as we start this trainer up, we're going to be able to see a new total, and we'll come back and take a look at that here in a minute. So we drop out of here. We've gone through all the menu options, and the last thing we got here is the diagnostics. So if you come into the diagnostics, basically right now, this is what this is about. If there's something wrong with this meter, something wrong with the measurement, it's going to show you right here. You can see the actual diagnostics is S962, which is an empty pipe air. All right. What you see up here is that air keeps flashing up about every 5 seconds. So it's going to say the S192 empty pipe air, and we'll know that we've got no fluid in that pipe. Okay. So the assigned simulation process variable, we're not going to go into that right now. We're going to go ahead and go back. We're going to put this on the, go back into application. We're going to look at the measured values, and we're going to go ahead and fire this thing up, and we're going to watch this thing change here. So I'm going to fire the trainer up, and it's going to get loud. And we're going to watch this flow rate change. So we'll come up here, take a look at this. Look at that temperature drop. Like I said, as soon as we get water going through there, it's going to cool the electronics. As It's probably a thermistor on a word in there, and that thermistor is just getting warmed up when it was sitting there without any water in there. Now we got water going through there, it's cooling the whole meter down, and so that's one way that we kind of infer what the process fluid temperature is with that sensor in there, all right? You can see we've got 13.24 gallon per minute, and if we come down and take a look at that, we can see that we actually have 13.24 gallon per minute on our Smart Blue app. You can see the temperature, and you can see my totalizer going up too, right? So as this thing runs, the total number of gallons that have gone through this meter continue to rise and rise and rise. So that's it, basically, for the setup of the DMA20. This is a pretty simple instrument. This is something that you can pretty much set it up and forget it at the end of the day. You're going to see a ton of magnetic flow meters in applications out there, especially in the food and the processing industry. They're just everywhere. They are a go-to, they're low maintenance, and as you can see, they're pretty easy to work with. So